So we can now actually get started with Basecamp session 4. And today we have Yang Ganana. So she's also one of my co-workers at the Starknet Foundation, also a developer advocate. And she's going to be your teacher today. And the focus of today is going to be smart contracts, right? So we focused on Cairo last week. So now let's go use Cairo for actually building smart contracts on a Starknet.
Today's workshop is split into largely two parts. One is going to be theory, which I feel like I want to run through, but it is also important to kind of understand and set the context of why you would see certain pieces of code in smart contract and what those pieces mean. Right. So that's going to be your first two sessions, which is like classes and instances and your smart contract anatomy. And then we are going to go to the second half, which is live coding. I'm hoping to spend at least 40 to 45 minutes at the counter workshop. It's a very well designed workshop, again, by Robert. And I believe David also had some hand in kind of putting it together. So huge credits to everyone for making this happen. Also, we have added a few resources that will be helpful. And the last thing is, I will be switching between screens a little bit to explain certain concepts, because I felt like rather than screenshotting, maybe I will just directly go and show you the examples. So in case my screen is not changing or anything, just please feel free to let me know or let David know in the chat, and I'll kind of make sure that everything that needs to be shared is shared. Okay. Quick introduction about myself. David already introduced me. I'm Gyan. Everyone calls me Gyan, so you can also just call me that. But my LinkedIn name is Jnana Lakshmi. That's how you can find me on LinkedIn. And I'm a developer advocate at the Starknet Foundation. And I'm born and I'm based in India. So another disclaimer is that it's about 9:42 p.m. And by the time this workshop ends, it's going to be 11:30 p.m. So in between, I may get foggy brained. So if I'm saying something stupid, feel free to correct me on the DMs, like, or on just on the chat. Like, I don't mind if you say that, oh, like maybe you're not saying something right. But hopefully, I would get everything right before the sleep time hits. Okay. And I can speak English, Hindi, Tamil, and a bit of French. This is my Twitter if you want to follow me. Okay. So the first session is just all about understanding how the anatomy, how the classes, the contract classes and instances would look like. Let's quickly see this. I think you might have seen it in the previous session, but just to give you a quick recap, Cairo is a provable programming language, and we write smart contracts for Starknet in this provable programming language called Cairo. The syntax of this programming language is very similar to Rust. Since you're already doing Starklings and stuff, you might see all of those similarities. If you compare it to Rustlings, it's like quite similar. But you will see some small but noticeable changes when you're using this programming language to write a smart contract. So please make sure that those small changes can be very significant messages to the compiler, right? So that's something you want to make sure that you're keeping track of. Cairo programs compile to Sierra, which is a safe intermediate representation. We will try to take a look at some Sierra files, but of course they just look like hexadecimals and stuff. So we will take a small example of that as well. And the sequencer compiles Sierra to safe chasm. So chasm is Cairo assembly, which in the previous stage of Cairo, which was Cairo 0, the Cairo smart contracts directly used to compile to chasm. It had its own drawbacks and stuff like that. But now there is a safer version called Sierra, and then it compiles to a chasm, right? The chasm is the contract that the assembly which is actually deployed on Starknet. Now, in this one, like I mentioned, in the latest version of Cairo, the failed transactions are included in blocks. So in the earlier version of Cairo, these failed transactions were not included in blocks, and because of that were the cons that I was mentioning, like there's a potential of like DOS attacks and stuff. And this Sierra is the one that enables this to happen, the failed transaction. So being able to have a safe intermediate representation is what enables you to be able to add failed transactions into the blocks. And because of the failed transactions are added, the sequencer is always compensated. So you can't actually attack the sequencer and keep it bogged down. And we don't see the DOS vector as we used to see in Cairo 0. So you don't have to worry about Cairo 0. But I'm saying that we get questions sometimes like, why Sierra? Why do you have an intermediate representation? This is exactly why we have it. We want the contract to compile into a safe intermediate representation so that even if the proof is invalid, it becomes a failed transaction and we are able to include it in blocks. And CASM is Cairo assembly. Of course, from the CASM, we generate a validity proof, which then gets the proof goes to the verifier, and the verifier verifies the proof at the Ethereum layer. We'll see that in just a bit.
There's a question from Leon. What exactly does it mean to be safe in the case of Sierra and Chasm?
So the safe intermediate representation is kind of ensuring that the way your Cairo smart contract compiles, so it adds certain nuances to the way the compiled contract can be represented. For example, in the previous versions, there was no branching or anything that allowed certain conditions to take place. You didn't have the ability to have something like, if something happens, then take this particular action, else take this particular action. But now with Sierra, we have the ability to determine if the particular path that you are going through is correct, then your proof is valid. And if the path is incorrect, then the proof that you're generating is invalid. So this is one example of how you bring in safety. But there are a lot of like these other kind of nuances that that Sierra brings in when it comes to like types. I don't want to type safety is the wrong word, but basically being able to have a program that can generate a result that could be either valid or invalid. So Sierra brings you that ability to do that. Did I answer your question satisfactorily? David, maybe you want to add something?
Just maybe in a short sentence, that safe means that if the transaction execution fails, it can still be included in the block and can still be proven. Before it was not possible, so failed transactions were just pretty much ignored.
Yeah. Okay. So now, when you think of Starknet contracts, what are the different things that you get? So there are two things that you will see, you will notice when you are trying to work with a contract. So there are two steps to actually getting your written contract to on-chain. So the first step is called declaration, right? So if you don't declare your contract, then you will not be able to deploy your contract. So this is the first step. That is, you declare your contract to create a contract class, right? So this contract class consists of the Cairo code that is compiled to Sierra, the ABI, that is, which are the functions that are accessible, and it generates a class hash of your contract class, right? So the contracts that we write, the smart contracts that we'll write in Cairo, the first step that we do with them is to declare those contracts and generate a class hash of those contracts. So every time we modify the code, basically the the class hash changes. So this is the first step that you will always do with your smart contracts. Now, the second thing, the contract address that you find, like say on Starknet or whatever, that is actually a contract instance, which has its own storage, the associated class hash that you declared in the previous step, and it has its address, which is what we call as the contract address. So when you deploy a contract on Starknet, you are actually deploying an instance of the contract on Starknet. But in order to deploy an instance, you need to declare the class and have a class hash for yourself. So I have another diagram that kind of explains it nicely. That is, if you have a class hash, say 0x123, you can deploy multiple instances of that contract, each of them with their own storage, with their own, with this particular class hash, and having their own distinguishable contract address. So you can see here that the contract address is 0x981 and another contract address is 0x248. So these both are instances of this class hash. And there is another example with the same, which is you have another class hash and you can deploy multiple instances of this. So this is very useful because I know you might have, if you come from Solidity background or just object-oriented programming background, you might have heard of factory patterns, right? Where you have a top factory which can help upgrade contracts, or which can help call other classes, keeping the functionality the same in the object. Oops. So this kind of helps make the upgradability quite easy. And I'll show you an example towards the end if we have some time about the factory pattern and stuff. But just remember two things. So first, you have to always declare your contract to get a class hash, and you have to use that class hash to deploy an instance of that class hash, and then you get your contract address. Okay. Now, the next thing is, how do you alter the Starknet state, right? So once you deploy a contract, you can basically read from that contract. So these read calls are free. You can or you can write to the contract, where it's a transaction and you have to pay some gas fees. So read is more like call functions, and write are invoke functions. So let's see again what are the different types of transactions that you can do. The first one is declare. So you declare and you get a class hash. The second is if you have to invoke a particular instance, right? So if you have to invoke a function, you have to make some changes, or you're going to write in the contract. So that's going to be like, you're interacting with an instance of the contract. And the third type of transaction is deploying an account. So every account in Starknet is a smart contract account. So deploying an account is also a type of transaction. And even over there, you are deploying an instance, right? Because you are generating a contract address. That address basically becomes your wallet address that you work with in Starknet. So these are the different transactions types that we have on Starknet. And let's take a quick overview of how this would kind of look like. Just ignore this mempools. It's not the same as Ethereum mempools. Just think of all of these as transactions. So the sequencer receives the transaction. And over here, you basically, the sequencer is the one responsible for creating blocks. And it creates the blocks, and then you get this L2 block. And you create a trace and send it to the prover. The prover will create the proof, and it basically it runs and proves the Starknet OS. Then it sends the proof to the verifier, the generated proof, and the verifier will verify the proof on Ethereum. So you see, this is the L1, this is L2, and then you have Starknet core contracts that are also for interacting with the Starknet OS. And I think what is missing in the piece is like you have some data backup and like data nodes and stuff. Where you can create the backup for your L2. So this is like a simple way of kind of looking at how transactions work on. So when you deploy a smart contract also, they are going through the same process.
Some questions from John. Where are smart contracts stored? What format is the smart contract stored in? Sierra, binary format, or other format?
So the smart contract that you deploy on chain is in Chasm. So that is your Cairo assembly. So Cairo assembly is like binary format, and it is stored on chain.
The other question that we have is from Hui Xiao. What data are sent to the Starknet core? I can answer that one. So the data that is sent is basically all the root hashes from layer 2 blocks and the order that they exist on layer 2. And also the messages from layer 2 to layer 1 to be consumed as well. And the KCG commitment of the blob as well. Those three things.
Yeah, and they're sent. So the KCG commitment is sent in the form of a blob, but now we are sending all the call data also in the form of blobs, right?
No, so the DA data availability is sent as a blob, but then the KCG commitment is sent to the Starknet core for verification. There's also a small verification of that commitment to know that the integrity. I'm not that familiar with KCG, but it's something like that. Some verification of the data in the blob itself that has to be check and change. Another question from Nico Sanchez. So instances and deploy account transactions both are stored on chain?
You mean the I mean the contract, all of your accounts are contracts. So when you deploy a contract, it's stored on chain.
Yeah. So instances are regular smart contracts. Deploy accounts for account contracts is a particular type of smart contract, but they're all smart contracts, so they live also all on chain as well.
Yes. So instances is just another name for a contract. But we call them instances to differentiate them from class hashes. That's it.
John Han is asking on L1 or L2. I think it's connected to his previous question about where are smart contracts stored, on L1 or L2.
L1. Actually, L2. Sorry. On Starknet smart contracts are stored on RL2.
Yes, they're stored on layer 2. The only thing that it's sent to layer 1 is the
Proof.
class hash of the newly declared smart contract and the compiled class hash of the deployed smart contracts. That is part of the data availability. Yeah, but the bytecode itself lives on layer 2.
See, if you think about this, just yeah, like I wanted to say that if you think about just the concept of layer twos, right? The concept of layer twos is to be able to reduce, to increase scalability for layer ones. And that brings us to two concepts, which is storage and processing ability. So if we think of this in this manner, that if we start storing everything on layer one, then we are not actually achieving scalability at the level that we want to. So whatever we can do off chain, so this is off chain in the context of L1, right? Whatever we can do off chain, both storage and processing, we are trying to do off chain so that we can increase scalability for Ethereum, which is L1.
Cool. No more questions for now.
Okay, so yeah, and then what can you do with all that you learned? That is Starknet smart contracts. You can build on-chain games. You can work on things like Giza, which is verifiable neural network execution. Please don't ask me what this does because I have no clue. But I have some ML background, but I don't know what is happening at the intersection of ML and blockchain. So, but whatever is happening, it's like really cool cutting edge stuff. App chains, of course, we have Madara, L3s, that whole narrative of building your own app chain, being able to customize things as per your application and your users' needs. We have a ZK EVM project, which is Kakarot, which is writing EVM opcodes in Cairo. Very, very interesting. And they are just about to launch, I think, mainnet. They are doing a lot of rigorous testing, stress testing, and all of that. And yeah, a lot of other cool stuff, right? This basically explores the world for you to build anything on chain, but with being able to pay lesser gas fees and not worry about scalability issues. Okay.
Question from Manav. What is app chains and ZK EVM?
Okay, this is going to take a long time, but I'm just going to say that app chains, think of app chains as building using existing components. Like, for example, you use Starknet's consensus or the proof mechanism or whatever it is that you want to use. And you build a smaller sort of blockchain for your own application. So if you're building something very specific, like you're building an application which is for esports or which is for some sort of prediction marketplace or something like that, and you want to customize your own components, like you want to customize your own sort of mini consensus, you want to use existing consensus and customize some other things, right? A blockchain is not just consensus or just settlement or it has so many other layers. You have execution layer, you have consensus layer, and all of that. So if you decide that you want to customize it because you have a specific problem statement, you can build something called as an app chain. So as the name suggests, it is a chain specifically for your application. And why are they called L3s is because when you think of customization, you're not building everything from scratch. You're already using existing mechanisms of L2s or L1s. So that's why they are being called L3, because you're building another layer on top of these existing layers, and you're picking some of the, you're sort of like cherry picking some of the existing components, adding your own components and making your own chain. So those are app chains. There is a lot of information that's there about app chains that you can also read online, and I'm happy to answer more questions on this one. Okay, ZK EVM is a VM that is working like EVM, but can create zero knowledge proofs. So the way EVM stands as of now, It's not optimized, neither is it built for actually creating zero knowledge proofs. That's why we have built something called as Cairo VM, which is optimized to generate zero knowledge proofs. However, because the EVM narrative has been there for a long time, there are lots of developers who are already building in Solidity. Some projects decided that they will build a ZK EVM, which is an EVM-like virtual machine, right? Which that virtual machine can run all of the opcodes of EVM, but it can also generate zero knowledge proofs. So in the most succinct way possible, this is what ZK EVMs are. Obviously, they are way more complicated and have different ZK EVMs have different architectures. The ZK EVM that is built using Cairo is called Kakarot. You see the symbol K, and they have implemented these EVM opcodes in Cairo. Now, what that says about this VM is that this particular ZK EVM called Kakarot can also create ZK proofs because Cairo is a provable programming language. They have just implemented the EVM opcodes in Cairo. So this VM can also run the same instructions as EVM. Is that clear? Is that too much?
For now, no more questions, so we can continue moving on.
Okay. So smart contract anatomy. So now we are going to start a little bit into like looking at different pieces of code. After these slides, there's someone who raised the hand, David. Two people have raised their hands. Okay, so so all of the next slides you'll just be looking at pieces of code and understanding what these pieces of code look like, what these pieces of code mean. A compilation of all of these pieces of code is just your smart contract, right? So I've just put different pieces in different slides, and then it all comes together and becomes a smart contract eventually. So the first thing is this is how a bare minimum Starknet smart contract written in Cairo looks like. So what I'm saying is you can't just write something like mod counter contract without any of these annotations and just open close braces. That's not a bare minimum contract. A bare minimum contract will have this annotation, which is your Starknet : contract. This is because, like I mentioned earlier, Cairo in itself is a provable programming language. So when we are writing a smart contract for Starknet in Cairo, we have to let the compiler know that this is a smart contract. So we have to annotate it as a Starknet contract. And Starknet contracts, smart contracts, are Cairo modules. So when you want to write a contract, you say mod, which is the module, name of the contract, open close braces. And then you have to have a storage defined. So a smart contract must have a storage defined, even if it is empty. So now this is your bare minimum Starknet smart contract written in Cairo. Let's go to the next one. Now the next thing that we're gonna keep on adding elements to this bare minimum smart contract, right? The first thing we are adding is of course a variable inside the storage. So we have a storage variable called counter. Now, storage variables are variables that can be accessed, that can be modified, that can be written to, that can be read from, and you can access these storage variables throughout the contract. So now the first thing that we always have is a constructor. So a constructor is like an initialization function. So you have to annotate it as constructor, and the same way for storage, you have to annotate it as storage. So you add it's nothing but a function, the constructor. So the keyword for that is fn. For every function, the keyword is fn. Fn, then it's best practice to name it constructor, right? It must be called constructor. And then you have arguments of the constructor that you see here. One is called ref self, the type of the argument. The second name of the argument is initial counter, and the type is U32. I'll talk about what is this ref self in a bit. So these are arguments to the constructor. And then in this constructor, we are basically writing some type of value, which is this initial counter, to this storage variable, right? And we are saying that take this storage variable within my contract and then write to it this new value. Okay, this is what this is doing. And the constructor is only called once when the contract is deployed. And if you don't have anything to initialize, then you can just omit the constructor. It's not something that you need to have mandatorily, right? Simple. So the next thing, of course, once you have your storage, once you have your constructor, the next you're going to start adding functionality to your contract, right? So we come to functions. So to write a function, you use the fn keyword, name of the function, then you send arguments within the function, right? And if you want to return something, if you want to return a variable, your function returns a variable, then you use this arrow symbol and then write the type of the return variable. Then within open close parenthesis, open close curly braces, you write the logic of your function, right? This is a simple way to define a function. Now, but the topic of this is not defining a function. It's called exposing functions. What does that mean? This means that how can you access your contract functions? What are the different things behind being able to access your contract function? Now, the first and the foremost important thing is that whenever you are having your main implementation block, right? So in Cairo, in Starknet smart contracts in Cairo, you have this concept of interfaces and implementations. Interfaces are defined as traits, right? Which in English means characteristics of this contract, which we will also talk about in just a bit. But each of these interfaces define what is going to be the blueprint of this contract. That is, what are the different functions that this contract is going to have? What is largely the logic of this contract? And then you implement those functions in an implementation of that particular interface, right? And this particular implementation has two functions in this case, which is a get counter and the increase counter. Now, for this implementation block, if you want these functions to be able to be called external, then you have to add this annotation called ABI embed underscore V0. This is an important annotation that tells the compiler that this particular implementation block can be called externally, right? So this is the first thing that you need to understand. Now, the other different, so now automatically you're exposing these functions to being able to be called externally, okay? Now, what are the other nuances of calling a function? Either a function can be a read-only function where you are just reading the storage variable, for example, in that function. Or there can be a write function where we are manipulating a storage variable. So let's see what are some nuances defined in the function in order to do that. So when you have a read-only function, that is a view function, you will see this format, which is self and then colon at contract state. So this self says that the contract state. So I want to access the contract state of this particular contract, which includes your storage variable, right? But I don't want to manipulate it. I just want to read it. So I'm going to access a snapshot of the contract state. So the at refers to a snapshot. So the read-only functions take a snapshot of this state as a parameter, and then you can read the value. So for example, counter is the storage variable. You can read the storage variable using self. So in every function that you define, self should be the first mandatory variable, because using self is how you can access the contract state of that function. So you see in every function that you will see self. However, you will see self depending written in a way whether it is a view only contract or whether it is a write state, whether it is a view only function or whether you are actually doing some write. Now for the view only, we saw that the self is just a snapshot of the contract state. Now in this case, which is where you are writing something, you are using a reference, right? So you're taking a mutable reference to the contract state. So you see, you are saying that this self is actually a reference and you're taking a mutable reference to the contract state, which allows you to perform a write operation. If you remove the ref in this case and you try to write it, you will not be allowed, right? So there are three takeaways from this particular slide of exposing functions. One is you want to expose all of your functions within an implementation block to be able to be called externally. So you need to add an ABI embed annotation. Another is, now we come to the function themselves. If the function is read only. It's only doing read operations. You can have a self parameter, and this only takes the snapshot of the state as a parameter. So you will see the at. And or if you want to write, then you have to take a reference, and this takes a reference, mutable reference of the state. Of course, this costs gas, and this is free, right? Okay. Why do we have this syntax? Because it is for better maintainability, and then you get a compiler error on type mismatch. So it's good. Plus, it is important because you deal with a lot of state changes in blockchain just in general, and it is like you see a lot of hacks happen because there isn't proper access control, or there is a lack of understanding of how which functions, which part of code can access which other part of code, right? So this kind of gives you a better understanding of what is read only, what is external or write, and things like that. Okay.
There's a couple of
Are there
questions. Yes, a couple of
okay.
questions. Question one from Seth. Why is the type of ref self a contract state, but not counter contract? If it's contract state, how does it infer the storage properties in counter contract since they are different?
So I don't understand the reference to the counter contract. Maybe there is a confusion because the full contract is not here. But basically, this counter contract is not. It doesn't have anything to do with the state. The counter contract is actually a trait. So let me see if I have. Yeah. So you see this interfaces. Basically, this I counter contract is the interface that is over here. This interface has two functions, which is get counter and increase counter. And this particular interface takes a generic variable called T contract state. So this like T, I think you might have seen is like generics, right? So this takes a generic variable, and you are telling this one whether you're going to take the snapshot of the generic variable, or you're going to allow to write to that generic variable. Now, the variable that you're using over here to read or write is the contract state. So you see over here, we are using the same variable, which is contract state. This counter contract is an implementation of this interface. So maybe it is clearer if I cover this slide. So let me cover this and come back to all the questions, because maybe that's a bit of a confusion in which I have arranged the slides. Okay, I'll cover this quickly. I already covered most part of it already. So like I mentioned, in order to communicate to other people that what a particular contract would be doing, right? You actually write an interface, right? An interface is like a blueprint of a contract, that what are the functions will this particular contract have. And you can also see like the arguments, what are the type of functions, are they view functions, are they write functions, or what, right? So interfaces in Starknet require this annotation, which is hash Starknet interface, and they are declared in the form of traits. So you have to use the keyword trait. Then we use I to denote that this is an interface, right? So we have I, and then this is an interface for the counter contract, right? That this is what we are writing. So we have the this trait called I counter contract, and within this is basically what is the generic object that this trait is going to act upon, right? So this trait is basically telling that these are the functions that are part of my program, and these functions are going to act on a particular type of variable. Got it? So that in this case, we are keeping it generic. So when we implement this trait, we can tell what type of variable is it upon which the functions of this trait will act. So we give that type of variable in the implementation. So we have this trait, and then we have a generic. Okay, this can be whatever. This can just be T also, right? I am used to just writing as T, but because just to let you know that we are actually going to modify the contract state, we have written it as T contract state. So you might have commonly seen it in Rust and other programming languages as just T. So it doesn't matter. If it is T here, it should be T here, and it should be T here. That's it. Right? It's a generic variable that we're representing. Within this trait, we are telling that there are going to be two functions. One function is called get counter. So we are just going to give the blueprint of the function. There's no implementation of this function. So we're going to say that the function name is going to be get counter, right? this is not taking any other arguments except self argument, right? That means the self argument is required to access the contract state. So self, and it is going to take the snapshot. It's not going to write. So it's just going to read. And with arrow, whatever comes after is the return type. So this is a type of variable that is going to return. It's going to return a U32. And the second function is an increase counter, which is a reference, like basically you're giving a reference. So you're going to be having a mutable access to this type of variable. And this also tells us clearly that this is a function which is going to aiming to write something, right? So now we have the blueprint of this. Once we have the blueprint within our contract, we can implement how we want, what is the functionality of these functions. So this is where we are saying that we are going to implement the counter contract, right? The functionality now. And we say super because the interface is defined above. We'll do this in the counter workshop as well. So most part of the code is here already. So we have this. So what we are doing is the I counter contract is the interface, and now we are saying that we want to modify the contract state. So we are giving the contract state as the instead of the generics, right? Instead of T, we replace by contract state, and we are going to implement the functionality that the blueprint gave us. And the functionality has two functions: get the counter, which just returns a U32, and increase the counter, which is doing some, operations here. Okay, now let me tackle, should I cover types of interfaces also and then tackle the questions, or?
No, I think it's going to make more sense when you do the live coding than the slides, I
Yeah.
feel.
Yeah, that's true. Okay, then let me just quickly skip through this because I think we are nearing the break. So maybe I can close the slides before the break, right? Okay, so quickly, this one I have already explained. So these are called explicit interfaces, where you define the interface and then you implement the interface. So everything you're doing explicitly. You're saying that here is the interface, this is the blueprint, and then you are going to implement the same interface with the functions that you have defined inside the blueprint. Okay, so that's why they are called explicit blueprints, and then so explicit interfaces. And then you have I already shared this ABI embed for enabling the functions to be called externally. However, you can also have something called as implicit interfaces. These implicit interfaces can be of two types. One is you can have an implicit interface where you don't have the interface itself is not written above. So you're saying that generate this trait for me. That is, I'm writing the implementation. You just generate a trait for it internally. Okay. So this is more like an implicit interface. Now, in this case, we have mentioned that these functions should be external, and we have to also mention the ABI. So in order for these to be called externally, there is another way to do the same implicit interface where we don't mention this ABI per item, nor do we mention these external V0. Imagine that these three lines are gone. Okay. The orange lines, ABI per item, external V0, both are gone. But we have the generate, and we have some functions that we are having inside an implementation. These will be automatically private functions and internal functions. So you can't call them externally. So if you want to have some internal functions that you just want to want to call from inside, then also you can create an implementation and have add the generate trait annotation to it. So it will automatically implicitly generate a trait for you. So these are the two differences. I'm also gonna quickly run through events. So of course, in order to communicate with the world what is happening in your smart contract, you want events, right? And for events, you have to think of events as having two types of structures. Okay, the first is an enum called event that you have to define, and you have to tag it as an event, right? So that's when the compiler knows that you are now defining some events for your contract. You're going to define some events for your contract. So you say that I want to create events for my contract. So you create an enum called event, you tag it with event, and then it has to derive this property that it's a Starknet event. So this Starknet from which the event is being derived is already published as a part of the core like Cairo libs. And you are basically extracting, deriving that event property for this particular enum, right? So drop is another property so that it can be deleted. So it can be dropped. That's the idea. Now, the first part of this is that now inside the enum, you declare the name of the structs, which are actually the events. So you declare the events inside your enum. So this is the name of the event and this is the type of the event. So both are the same in our case. And as you keep writing more and more events at the moment, you will keep them as the same name. So now for this, so you can define multiple events inside this enum. Okay. So for example, ownership transferred, ownership regained, something triggered, transfer triggered or something like that. You can define multiple events inside this enum. Now, in order to define what will be emitted as part of this events, you have to create a structure. So the events themselves are always defined as structs. So these structs also have to derive the event property from the Starknet lib. So you're deriving both drop and event property for this particular struct. And then you give the parameters that this particular event will emit. So for example, this ownership transferred event is going to emit a previous owner, right, of type contract address and the new owner of type contract address. So who was the previous owner and who was the new owner? Now you might see a small additional thing called the key, which is basically to index this event faster. So when you're querying the blockchain and you want to do a quick search, right? So this key will allow you to index this event faster. So that's the whole purpose of adding this key to it. Okay, yeah. So this is basically you have to remember that an event requires two things. An enum called event, within which you will declare what are the different events that you want to have. And each of these events are actually defined as structs, within which you will write the parameters that you want to emit. Okay, I think this is probably around my last slide or something before we go to hands-on. Now, the last thing that we're going to talk about is how do you call one contract from another contract, right? So calling one contract from another contract. You can do that using this concept called dispatchers. So in Starknet, in Cairo contracts, you can dispatches are automatically generated from interfaces. So for example, when you're writing this interface called iData, which has two functions, get data and set data, right? This is a blueprint of your contract, right? There is automatically a dispatcher that is generated for it as iData dispatcher. So there are two dispatchers that are generated. One is iData dispatcher and a trait for it, which is the iData dispatcher trait, right? So this is automatically generated from interfaces. So we have to use these dispatchers to be able to call the external contracts. So in this case, for example, we have a contract called my contract, which needs to call some, function within this iData trait. So think of this as like there is there's like another callee contract, right? So what we can do is we are going to get the iData dispatcher and the iData dispatcher trait, right, of this particular interface that we need to import into our contract. And the way we call it is like this. So this is the ABI embed V0. That means this function can be called externally, right? And we are taking two parameters, the contract state. So we are not modifying the contract state. And we are taking a data address, which is the contract address of this particular contract, right? And what we are going to do is we are going to call this iData dispatcher with this particular contract address. This will call this particular contract and give us the address, for example. So this will give us the contract instance of this particular data contract. And using this contract instance, we can call the function within this contract. So using a dispatcher, the function is executing with the storage and context of the targeted contract, right? And then we have another type of dispatcher, which I'm not going to go into, which is the library dispatcher. So you use this to call a function in a stateless manner using the storage and context of the current contract. So let's not worry about this. For now, we will work with this, which is also going to be part of your homework. So the main things that you have to remember, the one main key thing you have to remember is whenever you're writing an interface, there's going to be an automatic dispatcher that is generated for that interface. And using that dispatcher, you can directly call that particular contract, which implements that interface. As simple as that. So this is how you call an external contract from within another contract. Okay, now this components is slightly new. Like it's just like, think of these more as like libraries or key components of for modularity. So the way components look, it's very similar to the way a contract looks, but components are for the purpose of bringing modularity. So they can contain functions, storage, and events, and they are more like modular add-ons that you can use in your contract. So for example, think about an ownable contract, right? It is something which is very commonly used in Solidity, like to check whether a particular contract address is actually owner or not. So imagine that if you can publish that ownable contract as a component, you can use that component within your contract and call certain functionalities. So that's the whole point of like components. Components become part of the contract's bytecode. So you basically use the components within your contract, and they become part of your bytecode. So you can publish components, right? And it can be implemented in multiple contracts. So this is a good example, but it doesn't have how to use the component. So I'm going to share my screen and show you a very quick example. Oops, wait. Are you able to see my entire window now?
Yes.
Okay, perfect. Okay. So I want to show the components example from here. Yeah, okay. I'm also going to share the link with you. We don't have to worry too much about it. It's not part of our counter contract anyway, but it's just good to know like that this modularity, idea exists. So instead of marking it as a Starknet contract, you mark it as a Starknet component. You see, it has very similar sort of vibe as your contract. So it has the interface, and then it has it's defined as a module, and it has a storage. This one has an event, right? So you see that this has an event, and this is the struct, that is the event itself defined as the struct. And it has an implementation. It has two implementations. One is an embedded implementation, and one is a implicit implementation. And the way you use this component in a contract, this is the piece that was missing in that screenshot, which I want to share, which is you have your contract and then you kind of just take the implementation from the component, right? And this is the switchable component. It had the this particular implementation, and then it has this another internal implementation, which was this one. So you see there's one implementation, there's another implementation. We are taking both of these implementations over here, right? And we are just calling the functionality. That's it. So this is the way you can use the components. So you can publish this as a component, and then you use the implementation of this. There is more deep dive on the Cairo book as well, but we are just like just going through like sort of just breezing through these concepts, so you are familiar that okay, like this exists. So I hope that whatever you saw until now can be useful now that you start to write the code. The first and the foremost thing that I want you to do is I've shared a GitHub link that please go to that GitHub link will lead you here, the GitHub repository for the counter workshop. Please clone this repository onto your systems, please. So you can copy and then like, let me go to my terminal. Okay, some random stuff open. Okay, so I would suggest that you kind of create a new directory for yourself. So let me actually do that. I'm going to Basecamp cohort 9. So within Basecamp cohort 9, I'm going to clone this. So please could you raise your hands once you have done it? Yes, the GitHub repo. I pasted it here in the chat.
Remember the last session, Robert showed you how to set up the dependencies like Scarp and Starknet Forge. So you should have that in your system already for doing the live coding.
You don't need to fork it. You can just clone it, because you're not going to submit any like PRs or something. So you don't need to fork it. Okay. And also we would need we would need these installations already installed. So Robert mentioned that he has already done the installation in the previous session. So you should already have ASDF, you should have SCARB 2.6.4, you should have Starknet Foundry 0.23.0, and the Cairo 1 extension for VS Code. So could
The
participants
other
or
option will be to use Docker if you feel more comfortable with that. That
Yes.
instructions is shown there.
Yes. So if you would like to use Docker as well, you can use Docker. So I'm going to do the without Docker version, but everything that you're doing should also run within the Docker as well. How about Remix? You can write the entire contract on Remix as well. But the thing is, here we are gonna do it step by step. So you will not be able to test it. And we have already written the test cases for it within this repository. So it's better to do it with this repository. But once you complete the contract, you can also write the same contract on Remix. However, this repo already comes with the test cases. So you would know whether the code that you wrote is actually correct or not. So this is going to be a very simple like follow along workshop. Literally all the instructions that you need are here. I'm just a mic for these instructions. That is, I'm just going to repeat these instructions that are already here and maybe talk a little bit about why we are doing what we are doing. A major part of whatever we are doing, you have already seen how that code looks like on the slides, right? So now you have some sort of recall value that you want to get from there when we are solving these problems, right? Hands-on. So that was the reason why we have slides. We can try other sort of things as well later on. But yeah, so let's go for the workshop. So now I have my terminal and I have this the GitHub opened as well. And I'm just going to follow the instructions step by step. Okay. The way we are going to do this is we are going to look at, so the first step I'm going to do with you. And then the next step onwards, right? What I'm going to do is I'm going to read out the step. I'm going to give you some hints, which are already there over here. And then I'm going to tell you that, hey, I'm going to wait for you for a minute or two until you try to attempt to do this step yourself. And if you fail or you're not sure how to attempt this step, then I'm going to just come back to it after 2 minutes or so. Okay. We're going to do it that way. I'm going to let you attempt the steps and then I'm going to get you into the so the next as we keep going, you will become faster and faster, and the need for me to just attempt this itself will kind of go away. That's the objective, right? So let's do the first step together. Okay, so we're going to do we are just copy the git checkout b step 1, which means that we are branching to a different branch. Okay, so I'm going to clear here. And I'm also, after I clone the repository, I did cd counter workshop. Okay, so I'm inside this repository now. And I'm just going to check out and move to the first step. Okay, this is a branch, which is our first step. Okay, so let's see first what we have inside this branch. So I'm going to open my code editor. I have a VS code. I'm also going to see the folders here. You can see that there are some Git folders. Never mind. There's a tool versions, which expects you to have a specific version of the different toolset that we have, which is mentioned in the GitHub as well. Okay. There's a README, of course, and then you have scripts. You have a scripts folder and you have a Docker compose for if you're doing it via Docker. Okay. There is nothing else over here as of now. We are at step 1, right? And then what I'm going to do is I'm going to open this in the code editor just in case. I'm going to do this for all the steps to see just again to, take a look and stuff. We saw the files, right? The tool versions that we need are Starknet Foundry 0.23.0 and Scarp 2.6.4. Okay. So I'm hoping you all have this. Many of you have raised your hands. Okay. So now what is the goal of this particular step? The goal of this step is we need to initialize the project structure within the clone repository by using the Scarb package manager and enable compilation of Starknet contracts. So there are multiple things to this requirement, okay? When we initialize the project with Scarb, so the first thing that we need to do is initialize the project structure using Scarb. So Scarb is a package manager which is used to manage your Starknet smart contracts. It is used to actually manage Cairo individual Cairo programs as well as Starknet smart contracts. For us, we are now looking at Starknet smart contracts. So if you're familiar with Rust, then Cargo is a package manager for Rust. Similar to that, Scarb is your package manager for managing your Starknet smart contracts, Cairo smart contracts. Okay. And because it is by default a package manager for Cairo, you have to enable the compilation of Starknet contracts by adding some things to the configuration of this package manager. Okay, this is what this goal is. It's asking us to achieve this goal. So what are the specific requirements? Specific requirements are when we initialize the project with Scarb, we have to name the package as counter. And we have to do it within the cloned repository. Okay, so we have all the hints now. We are within the cloned repository. Now let's see what it means to initialize a project with Scarb. So how do you know what are the different things that Scarb can do? You can just type Scarb help. Okay, we see that Scarb has different commands like we can add, remove, build, check, cache, clean, and all of that. And then we come to init, which is what we want to do because it's asking us to initialize. But there is a catch to it. We need to name the package as counter, right? So let's go to Scarb init and ask for help. So there is an option called name that we can add, which sets the resulting package name, right? And it defaults to the directory name. Remember that the directory name is counter workshop, but the instruction for us is to name the package as counter. So let's do Scarb init -- name and counter. Okay, so we get some warning that the git ignore file already exists. Right, we are trying to initialize this, so it says that git ignore exists. I don't have to worry about it. Now it says it has created a package. We have already opened our code editor, so let's see what that means. Okay, so now in our counter workshop code editor, we can see that few more folders have been created. We have this folder, we have a file called scarb.toml that got created for us. We have a source folder that got created. Initially, we only had scripts and we had this readme and all of that, tool versions we had. So inside the source, there is a default file called lib.cairo that has been created for us. And this has the code of a Fibonacci series, if you're familiar with that. This implements a Fibonacci program, and there is a test case for this program. So this already lib.cairo has a default code, and if this source folder has been created for us, has been generated for us. Okay, so far so good. So we have gone through the first instruction. So whenever you initialize a new project with Scarb, you will get a source folder with the lib.cairo, which is the default file, and it will have the pieces of code in it. So you might have seen, I think even Starklinks uses Scarb. So you might have seen that you have different files, and then there is a lib that encompasses all of them together. And then you have a scarb.toml and all of that. Okay. The scarb.toml is actually a configuration file, which we will see now. Okay. So it says that create a new Cairo file under the source directory named counter.cairo and add the following starting code. Okay. So I've copied this starting code now. Oops, sorry, I'm gonna close this. To close this. No, you have too many editors open. Okay, so this is the one that we're looking for. Under source, it's asking us to create a counter.cairo and copy this code. Okay, I have copied it now. Now in the lib.cairo file, remove the code and define the counter module. So what we are going to do is we are going to remove this and we are going to say module counter. That's it. So whenever you define a new Cairo contract that you want to add inside your source, you can have multiple Cairo contracts here. But the entry point for this to be built, when Scar builds it, it looks for all of the files at lib.cairo. So if I just had counter.cairo separately, and I didn't mention the counter module here, and I still had the Fibonacci code, it would just build that Fibonacci code. It will not be able to find the counter contract. So that's why the best practice when you write code is you can have separate files which are for your different logics. And then define the modules in the lib.cairo. So when Scarb is building, it will be able to access these modules, right? It works the same when you are working with Cairo as well, or Starknet smart contracts written in Cairo. Okay, so now we learned how to basically create a Scarb project, how to create a new Cairo contract within our source, and how to add that as a module within the lib.cairo. And now they have asked us that initialize the project structure and enable the compilation. So let's try to build it now and see if this works. Okay, I'm going to save this. I've saved this, and I'm going to try and build it. Okay. Okay, so it builds. It gives me a target. Okay. However, there are some more things that we need to do in order to be able to get some type of in order to be able to get a chasm, right? To be able to create that assembly file that we can actually deploy. So in order to do that, we can check out the hints where we say that to enable Starknet contract compilation, we need to add a target as the Starknet contract. We need to specify the Cairo version in the scar.toml, right? So let's go over here. Let's look at the scar.toml. So we have to specify the Starknet version under dependencies. So we're going to say that we need version greater than 2.6.3. And we also need to provide a target as the Starknet contract. So this is the way that this Scar will be able to compile this particular contract, this particular piece of code as a Starknet smart contract. So we have to provide the target as Starknet contract. And then what will be the version of Cairo? So we say that Starknet greater than 2.6.3 is what we're looking for. So we have 2 greater than or equal to. So we can check this with the Scar version as well. And so all of these instructions we have cleared. That is, check out the Scar init command. So this was the hint, which, I did it for you directly so that you get the flow with me for the first step. So we have the Scar init command, Scar init -- name package name. And you can also refer to the cheat sheet for different type of Scarb commands. You can also do a Scarb help as I did. And then we need to enable Starknet contract compilation. So we need to add the target as Starknet contract, which I've added over here. And we can specify the Cairo version in the scarb.toml. So this is the version that I have specified. Now, again, if I do scarb build, it should. Okay, perfect. So now that you can see that after I did the scarb build this time, it has created a Starknet artifacts.json, which has the contract related artifacts, right? So at this point, we don't have anything much because the code itself doesn't have much stuff. But you can see that now after adding that dependency, I'm able to get the artifacts related to the contract itself. Otherwise, it was just compiling the Cairo code as the Sierra. Okay. So step one, how many of us are how many of you are on the same page as me with step one? So with step two, what I'm going to do is I'm just going to read this. I'm going to switch the step two, read the goal, and give you some time to implement step two yourselves. So please raise your hands if you're done with step one. Okay, let's see. Why is counter name in lib in small letters? So you see this module that I've created. It's in small letters, counter.cairo. So that's what I'm actually adding over here. That's why it's in small letters. Don't go by this one. It's the name of your file that it's trying to find. Yeah, I mean, right now it is this way, but David is right. You could use Pascal prefer. It's up to you. Yes. So you are getting this error, Mana, because you have not added the Starknet as the target. This one. Yes. So you can also check the Scarb version like this by doing Scarb -- version. Okay. So see, it asks for 2.6.4 and the Cairo version is 2.6.3. So we have done the dependency as greater than equal to 2.6.3. Okay. In chat, I see a few questions. Yeah, setting up on Windows can be a little tricky. To be honest, I don't recommend Windows If you want to learn compiler-heavy languages like Rust or Cairo, I recommend you to have a Linux virtual machine that you can spin up. Okay. Yeah, Mac is cool. I'm using Mac.
Tim is asking, what is the dependency again? Do we have any dependency?
Sorry, you mean snforge command not found. So for those who are facing dependency issues, please check this, which is initially you have this option 1. In case you're not using Docker, you need to install all of these dependencies. Oh, yes. So target Starknet contract is the dependency that, sorry, you mean the dependency here. So this dependency is basically the Starknet version that you're mentioning. So it is Starknet equal to whatever version of Starknet that you would like to use. So in this case, we are going to be using 2.6.3. And the target is to create a Starknet contract. Should we always use the latest version of the dependency? Yes, preferably. Latest stable version. Why I installed Scar when I cannot use it? Terminal cannot find it. It's probably because you have not installed it globally, or it's not like added to your path or something. It's not able to resolve. So the dependency, the question, if you're asking about this dependency, it's inside your scar.toml. But in order to overall work on this counter workshop, you need to have all of these dependencies in case you're not using Docker. If you're using Docker, the Docker comes with the dependencies. So someone was getting SNForge not found. That's because your Starknet Foundry you have not installed. But also you are not running anything related to SNForge. So you should not have that error right now. Yeah, so ZSH is not able to find your scarb. It's probably because it's not finding it in the profile or something. Can you so how do I don't remember what I did for setting my scarb, but I don't remember if I used any path related stuff, but it's most likely that. Could you try to just like reinstall your scarb? Like with ASDF global install, like just try that again and it will give you some message that you need to like maybe set a path or something. That's probably why you're not able to find. What should be the output? Yeah, you're not looking for any output, right? You are only looking, at least for step 1, you're just looking to make sure that you're able to run scar build successfully. See, the verification is also there for each step, that when you complete, build your project by running the following command and it should build successfully. That's it. Yes, carb version prints something for you. Yes, it should print your version. See, like this. No, you mean for Hui. For Hui, scarb itself is not found. So the version won't print anything. I think you have to uninstall and reinstall again. I think it's some path resolution. Okay, just in the interest of time, I'm gonna go to step 2. I'm sorry, like if you're facing setup issues, we'll definitely help you resolve them. But we have just few steps that I want to quickly run through. So those who are already set up, they don't feel like that, yeah. So, okay. With the power of the 12 who have raised their hands, moving on to the next step. With the next step, again, you just need to copy the step command. Okay. And I'm going to again paste this here. Okay, so now we switch to the branch step 2. Okay, for step 2, let's quickly see what is the goal. For step 2, the goal is to add SN4 as a dependency within your scarb.toml. Okay, now you know how to add dependencies on scarb.toml to allow execution of tests with Starknet Foundry. So Starknet Foundry is a framework which helps you write tests for your Starknet smart contracts, right? In Cairo, the same programming language. So we are going to add that particular SNForge as a dependency within our scarb.toml. So the requirements for to complete this step is in your scarb. Declare the SNForge underscore SCD package as your project dependency and enable Chasm contract class generation. In your scarb.toml, define a script named test to be able to run snforge test command. And in your scarb.toml, set your edition to target 2023_01. And once you have completed these steps, if you run scarb test, this will be successful for you. So how to do all of this? You can find it all in the hints. So when you are trying to add this snforge std package, you can find it from the Starknet Foundry documentation, how you can add that package, right? And remember to specify the version of Foundry that the project currently uses. That's a tweak you have to make from the example that's given here. Then how do you add the script? You have to add a script which is test pointing to snforge test. For that, you will find the documentation in this other link. And then the edition 2023 is a type of configuration that targets a general version of Cairo Prelude. So what the prelude is, you can find out more about this, but you don't have to go too much into it. Just make this change, add all of this, and you should run scar test. It should be successful. Okay. This is the step that you have to do. I'm going to give you 2 minutes to do this. And I'm going to check the chat. Okay. Is there a boilerplate for this, or I have to set this up every time I want to work on a project? Yes. So you
I'm
can.
maintaining a. Oh, sorry. Yes, go ahead.
Oh, no. I was just going to say that you can use Docker, but the scarb gives you the boilerplate to do everything. That's why we are making you do all of these exercises. That once you install scarb, you just have to make some changes in the toml file, set it up according to your expectations, and you're good to go. Because this is the first time there seems to be like a little bit of friction, but you're just literally setting up a project. Yeah, sorry, David, go ahead.
No, I was saying that I'm maintaining a Docker image for Cairo development that I'm gonna share here. It's actually a reference from the counter workshop as well.
Oh, yes. Yeah. Yeah, there is a Docker, this one as well, right? Okay.
Yeah.
So some people have completed step 2. Ankit has completed, I think, Nikabar, sorry if I'm pronouncing it wrongly. Nimble has also completed. And yeah, I'll wait for others, or I'll wait for 1 more minute actually, because I started at 11:11 and I told you I'll give you 2 minutes. So I'm gonna do my step in another minute. I mean, I will do the same steps. So 4 people were able to follow the instructions. It's still not bad because it's your first time. So if you're not able to find information, don't feel overwhelmed. It's completely okay. You are learning multiple things here. You are learning to find information that is coherent with the actions that you want to perform, right? And you're also figuring out like how to translate this information to something that's useful to you. So this is the first time, this is a new programming language. So if you feel like you're not getting it right the first time, it's completely okay. Like that's literally how I was also when I started learning Cairo. So these sessions are meant, Basecamp is meant for you to practice, to learn how to do these things so you can get over your initial friction. Okay, that was my TED Talk. 2 minutes are over. I'm going to go to the step now. Okay, so I have branched to step 2 and I'm going to do the same things as I mentioned I would. Okay, so I'm going to go to these. So there is the dev dependency. This is right here, right? This is what it asks you to add. I'm going to add it as a dev dependency itself. Okay. So I'm going to say here, because we are using version 0.23, I just need to make that small change. Okay. And then for the next step, it says that I need to change the, okay, I'll do this one first. Need to change the edition. So that is 2023_01. It also says actually that I need to enable CASM contract class generation. So I can do that under this target. So I say CASM is equal to true, right? So it will generate CASM files now. And the last one thing is define a script name test. So for this, you can check the scripts. How do you define scripts? So let's scroll down. So here it says scripts. Okay, I'm going to take this. I'm going to add scripts. Define a script name test, which should run snforge test, this command. Okay, so I've saved my file. Specify the version. Okay, so I have done this. that the project specify the version of Starknet Foundry. So I've done this. Refer to this for doing it. I also refer to the scripts, how to add, and then this addition. Okay. Now I have to do scarred test to check whether everything is correct or not. So let me do that. Okay. So now it says, okay, like it compiled it, and then it just ran, counter test saying that it works, right? So, and then test the SN forge, whether dependency is there or not, it works. Okay. So now if you go to your setup, if you go to your folder, you can see that there is a SN Foundry cache that got added because I added the SN Forge as a dependency, right? Over here. So it is, you can see that the dependency is coming from Foundry, which is the Starknet Foundry, which is used for writing tests, right? So you see that there is a cache folder that got created for it. And then in this step, you will also notice that a new folder got added, which is called tests. Within tests is where we have test_step.cairo. So you can see that a test has been written using SN Forge to test whether SN Forge has been installed correctly or not. And because we passed this assertion, we got successfully, we got a successful message on our terminal that yes, your tests have passed. So you see that this new folder got added in this step just to check whether we have added the testing dependency correctly or not. Okay, there are some questions on the chat. Okay, yeah, 2023-01 has a bigger prelude, so you have to import few things manually. Yeah, surprisingly, tests are failing on me with some visibility issues. Counter tests, utils deploy contract is not visible in this context. Which tests are you trying to run, Prince? Because the test that we are using does not have any in step 2. Yeah. But we have not written anything explicitly which is for, you're in step 3. Okay. We'll come to that now. Next one. Error identifier not found. Users, what identifier? It looks like it's not able to get your SN Forge dependency. Can you check whether you added the dependency in the, yeah, this identifier not found? Could you check whether what is your SN Forge version? And have you changed that version in your scarp.toml when you added the dev dependency? See, the dev dependency has a tag which has the version. Can you check whether you changed this version to 23.0 and you imported the dependency like this, snforge_std? And if you redirected the script to snforge test. Yes, Tim, looks like your dependency is correct. Could you also check what is your snforge version like this on the terminal, whether you are 2.3? If all of these are correct. If these are all matching, then should be good. And Mana, could you also check for the same? I feel like there might be some version mismatch. Okay, this seems correct. Can you try to save and okay. Prince had a mismatch with the prelude. Okay, this seems right. This is right. Chasm equal to true. This is also right. Counter seems similar. It is the same file. I don't know what the issue could be. David, when you were testing, did you find any issues that looked like this, which is this enabled identifier not found? Okay, okay. Dev dependence, dev dot. Oh, sorry. You have written dev dot, but it is dev hyphen. So that's why it's not finding your dependency. Yeah, that's what it seemed to me like. It was not able to find, but I didn't know why. Sorry, my bad. I also didn't notice. See, fog mind. Sorry, 11:20. Okay. Okay. So, Tim, please, if you could also just double check that. For Tim's also, I saw it all looks good only. Okay. Manav has written yes with double S's. So I'm hoping that his tests have passed. Okay, let's go to the yes, okay, great. So Tim, if you can just review your files, if not, I'll help you on Discord after the workshop as well. Okay, so let's go to step 3. And again, for step 3, I'm going to give you 2 minutes. After step, maybe I'll have to stop with step 5. I'll see. Let's see. Okay, let's go to step 3 and let's move to step 3 and see what step 3 requires us. With step 3, we need to implement the constructor function to initialize an input number and store a variable named counter within the contract. Okay. So this is easy peasy now. For you all, this should be easy. Just look at the counter contract. Okay. You already have a storage struct defined. You don't even have to define it separately. Why? Because a bare minimum contract needs a storage, right? Now, as per the requirements, you need to store a variable named counter and its type should be U32. Okay, simple. The next is you need to implement the constructor function that initializes the counter variable with the given input value. Now, for this one, you can take a reference from the documentation here, from the hints. There is documentation on how to write constructor. But now is where I'm hoping that your recall value kind of comes into picture, that you already saw how a constructor would look like. It needs, it's a function, right? And remember that if you are writing a value, which is what it is asking you to do, that initialize the counter, you need to have a ref self as the first parameter. And then you will give an input value that you need to write. And you have to remember that it has to have a constructor annotation. Okay, so these are things we have already looked at in the slides. So this should be very easy now to write this very quickly. I'm going to give you 1 more minute for this and then I'll start writing by myself. So if you're finished writing this, please raise your hands. You just need to do 2 things. Write a counter, define a counter variable and write a constructor to initialize the counter variable. That's it. Okay, Carlos has finished. I'm liking this. Yay, Carlos. If you're finished also, what you can do is run this card test and verify whether you're completed successfully or not. You can check for yourself. Okay, 4 people have completed. Now, okay, 1 minute over. So I'm going to go now. I mean, to complete. Okay, so I'm in step 3. I've already opened my this one. This has some weird kind of. The Zoom thing keeps coming for me. Trying to bring it down. Okay, nice. So I'm gonna write counter. Okay, U32. I'll say constructor. Okay, function constructor, ref self, a contract state because I want to modify that. And then I have to take some input, right? It has to be U32. And I say self dot the name of the variable counter, and I have to write the new input into this. Okay, perfect. Once I've completed, I can run scarp test. Oh my God, what have I done? Fail to get contract artifact for name equal to counter. Sorry, which file am I looking at? I think that's correct. If it expects me to also enable Sierra, check stored counter. Wait. I would have made some variable mistake. Counter, structure, counter. Okay, let's see. Oh, hey. Make sure Starknet target is correctly defined. It is defined. Maybe I should do the dependencies above. Wow. This is the magic of live coding. I have to debug live. Okay, let's see. Target Starknet contract. Let's see if I am in the same. Yes, I am. Constructor. If done. Yes, correct. Let's see. Contract address. It should be fine. Okay. Okay, let's move to the next step. Even if it didn't compile for me, hopefully it has compiled and worked for you. So
So what issue you having? I wasn't paying attention.
It says that for me, it says that I haven't defined the target correctly. It's failed to get the contract artifact for name is equal to counter.
Did you name the smart contract with capital C?
Yeah.
And what about the module? Like in the lib.cairo, is that?
It's correct only, but the file name is counter.cairo.
Oh,
Yeah,
right.
so
And that's the file name.
yeah.
It's not saved. The file is not saved. I wonder if that has
Maybe I've not saved it. That could be it.
the lib.cairo file is not saved.
Oh, I didn't make any changes to it, but I don't know. No, my Cairo counter.cairo was not saved, maybe. I don't know. Okay. Because in the previous one also it needed the counter. I mean, it needed the lib. So it found that and it did everything, I guess it was supposed to do. Okay. Yay, fun issues that we are encountering. Okay. It's already past the cutoff time, but we don't have too many more steps. So we don't have to worry about it. Just few more steps, which I'm sure some of you are already ahead. So let's go to step 4. And in step 4, what we need to do is we need to now get to the more nitty-gritty things, that is implement an interface. Okay. So we need to write an interface which will give us the blueprint of the contract, and we are going to do it in steps. So for the first step, which is step 4, we are going to write the interface with just the get counter function. The get counter function should return the value of the stored counter variable within the contract. So remember that get counter is not going to modify the contract state. It's only going to read. So the way you have to define the function is in such a way that it takes this snapshot, right? And you need to implement the interface also. So you need to write the interface and you need to implement it. So let's look at the requirements. Implement an interface for a function named getCounter, which returns the value of the counter variable. The getCounter function must be within the contracts interface named iCounter. So you have to name the interface as iCounter. You have to write the getCount. You have to define the getCounter inside the interface. And then you have to write an implementation which will implement this by just returning the value of the counter. You can take a look at the hints. But if you remember, every interface is defined as a trait. So you have to say trait iCounter and then have a generic variable. Inside that, you write your function, blueprint of your function, and put a Starknet interface tag on top of it. Within your contract, you have to implement this as a so that that implementation can also have external access. So you have already seen the blueprint of how this would look like, and you can quickly code it out. So maybe instead of giving you the 1 minute, I'll just write it alongside itself so we can save the time. So I'm going to do step 4 now. Okay, so first I will write a trait. So in order to say that this is a Starknet interface, I have to mark it as an annotation. And my trait should be called iCounter. And I define a generic object T to tell me that this trait will be modifying or reading, writing to some type of variable, right? And the function that I have to define is called getCounter. Because I'm just going to read, I'm not going to modify, I'm going to take a snapshot of this T, right? Whatever that variable is, and I have to return this counter, so U32. Now I'm going to implement this, right? So this is a trait, I have to implement this trait. So now to implement it, the first thing I want to do is have it as a external, I should be able to call the function externally. So I have embedded this to be able to call it externally as version 0. Okay. So I say implementation, iCounter, IMPL. So this is a very standard way of writing implementation. So I'm just going to follow that. Off. Now I'm going to write super because this particular trait is outside the scope of this module. So I have to write super to be able to access this iCounter. And then on what am I going to implement this trait? I'm going to have a contract state, which I can read or write from. So now I need to implement a get counter function. So function get underscore counter, right? Again, self and snapshot of the contract state because I'm not going to read anything. And I'm going to return a U32. So in order to return, I need to read the value of the counter. So I'll do self.counter.read. And I'm not putting any semicolon at the end, because the way the functions work, the way return works in these functions is that if you don't put a semicolon, this becomes the last statement of your line of your function. And if you don't put a semicolon, this automatically gets returned. So the last value that you write over here will automatically get returned. So similar to Rust. Okay, so I'm going to save this. Let's see if there are any other requirements. So to create a contract, you will need to define a trait with a name. The get counter function should only be able to read the state of the contract and not modify it. Okay, let's check. Okay, let me save it properly. Okay, so once you have completed this, your test should pass. You can also, once the class is done, you can also take a look at what are the tests that, they have written. What are the tests that are written and what is happening in the background? What are we testing for? Small things, of course, but what is happening? Okay, step 5. Let's go to step 5. So step 5 and step 6, and then we come to the checkpoint. Maybe I can stop at the checkpoint and you all can do the rest of it. There's one small thing that I want to after the checkpoint, but it will become too late, so that's fine. Okay, step 5. So we're going to get into step 5. How many of you were able to do step 4? 5 of you. You have raised your hands. So I'm assuming you have finished. 6, 7. Okay, good. Okay. Now we're going to go into step 5. So in step 5, we are going to have within the same interface, we have to write another function, which is increase counter, that increments the current value by 1. Okay. So this is easy peasy now. It's getting easier because we are getting a hang of the language now. Right. So within the same interface, so within the same trait, I'm going to write the increase counter. Okay. And now I have to modify the value. So I'm going to take a reference to that, to this particular variable. And I just need to increment by 1. So I don't have to have any input. Okay. So I'm going to add this to the implementation. So I'm going to say self.counter.write. But what do I need to write? Before writing, I need to first read the variable value. So I say read and then +1 because I just need to increment it. So I'm not returning anything here. So I can close the statement by putting a semicolon, right? So the execution ends here. So I've added this increase counter, which was asked for in the step 5. And it should be within the contracts interface name iCounter, right? So I've done the same. I'm going to, sorry, saving too many times. Okay. So scarp test and the tests have passed. Okay. So let's go to this step, which is step 6. Now this step, we have to be a bit more cautious because this is the last step for before we move to the change thing. And I will check with David whether we can give that as homework or we can do it now. Okay, so with step 6, what we are going to do is we are going to implement an event. Remember that whenever we are writing events in Cairo, in Starknet, in Cairo as a Starknet contract, we have to have 2 parts to the event. One is the enum called event, which will define the event itself. And then the event is actually, which will declare the event. The event is defined as a struct. Okay. So remember 2 parts. So I'm going to go to step 6 now, which is the event, right? Step 6. Okay. I go to this and I say, now I want an event. So first thing I have to do is have this tag, which is event. Okay. And then the event has to derive some traits, as I mentioned. It has to derive the drop trait, that is, it can be deleted, and it should derive the Starknet events trait. Event. I say events all the time. Okay. So this is how we know that this is an event. Okay. We need to have these parameters. And first we need to define an enum called event. Now they have asked us to define a specific event. So it is called counter increase. Okay. That's the name of our event. This is what it is checking for. Implement an event named counter increased. So I'm going to copy this name. I'm going to go back to my editor, right? And I'm going to write. Okay. So this is the only event they've asked us to define. Now I have to define this event as a struct. So for that, I don't need this tag, but I still need this tag. this event needs to derive the trades. So I'm going to put this tag. This is the name of my event, name of my struct. And what should it emit? What is the value that I should emit? When defining the counter variable within the counter increase struct, oh, okay, sorry. The event should emit the current value of counter variable every time the value is increased. So what should I emit? When should I emit? Both are here. So I'm going to emit counter whose value is U32. You already know. And we have been asked to add a key so that the event is easier to index. Okay, so I'm going to add the key here. All right. So now I have created this event. Now they are also asking me to emit the event in the increase counter function once the counter value has been incremented. So I've not shown you how to emit the event, but you can just check it out here in the hint. It's already there, but it is very straightforward. You use self.emit, name of the event, and then the value that you want to emit. So let's go back. So in the after the counter has been increased, so self.emit, name of our event is counter increase, and the value we are emitting is counter, and the value of this variable is coming from self.counter.read. You have to read the current value now, right? We wrote an updated value. So we are reading that, we're assigning it to whatever needs to be emitted, and we are emitting this event. So every time we increase the counter, we will be able to emit this event. Okay, saving. Okay. So this is the step 6, and we have reached the main checkpoint, which is we have written a simple basic smart contract where we are able to get the counter value, increment the counter value by 1, and emit whenever the counter value is increased. So this is our first checkpoint. David, after this checkpoint, there is a process which tells us how to deploy the contract using the deployment script. But it has few things that may take a bit of time, like creating a wallet, funding the wallet, and all of that. So do you think this can also be part of the homework itself?
Yeah, because in the form for the homework,
Yeah.
we also ask you for the address on a Starknet where you deployed. So
Perfect.
the steps is just defined in the README, right? So you can follow the steps and you will be able to deploy using the script.
Yes, yes. So you can deploy. Anyways, you will have to create a wallet for yourself on Azure or Bravos, and you will be deploying on that particular account. So you will be able to easily extract your contract address, and you can post it as part of the submission, and we can grade you accordingly. So once you give us the contract address, actually we can go to Starkscan and we can check whether your get counter and increment counter are both working properly or not. So we can perform those tests, and accordingly we'll give you the points. So by now you're able to write a basic smart contract. So you can take a quick look at the smart contract as well. We wrote the module first with the simple storage, then we added the counter and the constructor as well. The constructor is writing an initial value to this, whatever we are sending while deploying the contract. And then we have two functions that we have implemented, get counter and increase counter. So get counter is getting the current value of the counter, and increase is incrementing by 1. And every time we are incrementing, we are emitting an event called counter increased, and we are emitting the value of that counter. So, and for the implementation, I mean, we have written an interface which is being implemented. So this is like a simple smart contract. You know all the steps now to write the smart contract. And one of my small pro tips for you, like whenever you try to learn a new language, is that follow the process of read, write, test. Spend a lot of time in the beginning reading different types of contracts. Like don't put too much stress on yourself, like that you are not understanding the contract. Just read through lots of different Cairo contracts. Just look at the code. That's why, and when you look at something, right, when you start writing it, the recall value will be there. Otherwise, when you're starting to write programs in a new programming language, you won't know how to debug and where even the minutest of the things went wrong. But if you read a lot of code, right, it's not an advice that somebody generally gives to read code. but it worked really well for me. It works really well for me whenever I learn a new programming language. So just blindly spend 2-3 days reading from simplest to complex contracts, and you'll find a lot of smart contracts, Cairo contracts online. Just read them, right? Just read and familiarize yourself with the pattern of this programming language. Once you're familiar with the pattern, then start again writing small to complex smart contracts, and then go for testing as to whether your logic is correct or not, local testing, and then go for deploying on-chain and on-chain testing. So this should be the process that you should follow. Like, this is a very effective method of learning, and something very useful when it comes to like programming languages, especially to understand what the pattern of a programming language is. Yeah, that's like my small TED talk for the end. But if any questions are there, I'm happy to kind of also see.
Yeah. Question from Carlos. Is there any repo with a list of smart contracts grouped, perhaps for beginners, intermediate, DeFi, NFTs?
I don't think we have a repo kind of thing, but we have Starknet by example. It has a set of good contracts. It has ERC20. It has it was actually one of the things I wanted to go through also, but it has something called as applications, where you can find upgradable contract, a DeFi vault contract. You find an ERC20, and you also have a contract of constant product AMM. So, you have different types of contract that you can actually look at.
We have Open Zeppelin.
Yeah, Open Zeppelin also has some contracts. So you can go through that. And then Starknet book has few example contracts like voting contract also. So we have few here and there. But if it's a good idea, even we can just collate that these are just example contracts that you can take a look at.
All right. Thank you all for coming. I'll see you next week for our session of frontend.
Yes. Thanks, everyone.